Hey guys, I'm Nick, and today we will be creating this super satisfying and really easy and beginner-friendly effect in Houdini that you can see right now. First of all, I want to say thank you to every one of you who participated in the recent poll here on YouTube to kind of shape the content on this channel. So we will be focusing on Houdini, but also there will be Octane tips and tricks and project renderings in Cinema4D and some satisfying animations like this one. Just a quick reminder that if you want to support me and my channel, you can check out the project files on my Gumroad, link is in the description. You will find all the files, textures, lights, alembics, all that stuff for a very low price. So first of all, I would like to walk you through my collider setup, which is basically procedurally modeled. And I already know that some of you instantly just closed this tutorial because of seeing this one. But if you are feeling more comfortably doing just regular modeling in any other software, you can do that and then just import it using, let's say, file, and then you can just import here any FBX OBJ Alembic file, so you don't need to model that, but I will walk you through this setup in case you want to recreate it. So we have three parts, as you can see. It's a glass tube top with like holes to generate these strands, or I don't know, corals, these odd shapes. And we have the part that pushes everything up. So here I have, let's start with a tube, because it's just a tube. I added a poly extrude node. Here it's set distance to 0.3 and output back is enabled. And we have this cute little tube. Tube has 44 columns, height set to 3, radius scale to 0.9, and then I just wanted to rotate it, and you can skip that step, but still. So my initial idea, it was so something will be pushing it from the back, and you know these strands are here, but yeah, then I went with a vertical setup. So this transform here is very cool. It's minus $y min. It really keeps your geometry on the floor. Here I added 0.27 just because I needed that. But yeah, minus $y min really is a helpful expression. And then I added the group, and it's just basically a primitive group called tube. And this is used when exporting this to Cinema4D. This group, and if you export that as a Alembic file, that will be your face selection, and that's how you, having one mesh that's consolidated and just yeah, a single mesh, you can still attach materials to different parts. I ended up exporting 3 Alembics just because I wanted to just briefly manipulate the scale of this tube. But still, it's a good thing and you should know about that. Alright, so that's our tube, and right now let's create our top part with these protrusions. So here I have a circle, I added a poly extrude, and then I added a few groups, and these groups are basically selecting this edge here, and you can see that I'm using the keep by normals option here and the spread angle set to 63, and that's how I can keep just this face here selected due to its normals. Let me maybe, yeah, so basically if we go up, we will select all the faces. Now anything below 70, I think, is selecting only the top portion of it. And then I duplicated the group, just set the direction to be -1 instead of 1, and we're selecting this face here. Then I added a poly bevel just to make it a bit smoother, prettier. In a poly bevel, distance set to 0.17, divisions to 3, and here, important thing in the group, I targeted edge 1 and edge 2, my groups that I previously selected, because I don't want all these little edges to be also beveled and subdivided in a way. So then I applied the same transform, and yeah, absolutely the same transform. But the thing is, let's talk about these little protrusions that we can see here. So I create this little tube, and then I'm using Mops instancer, and yeah, basically what I'm doing, I set the distribution to be radial and just mess around with these options here. That's it. Very easy way. I'm still learning Mops myself. That's why there are no in-depth tutorials about like Mops. But this instancer is super cool, and if you don't have Mops, just YouTube how to install Mops in Houdini. It's easy setup, and the tools are really powerful. Then I just transformed these 3 iterations of instancer, merged them together, added normals, converted to polygons because it was mesh, and then added transform a bit, I think, and added the boolean. And in the boolean it's set to subtract a minus b, solid, everything default. Yeah, and we have this really cool looking disk with a few protrusions. Then we moved it back in tube a little bit, because you can see here it's ending, here starts where the tube ends, and I wanted it to be a bit more in the tube. Also added the group called top, because I wanted to access this mesh later in Cinema4D. And yeah, that's our tube. It's complete, it's everything is good. And then I merged these two, and we have our complete tube. Oh, but we forgot about our pusher. So starts with a circle, instantly add a UV texture, texture type set to cylindrical, because your textures will float if there is no UV texture node attached when you will be rendering it out. So then the poly extrude, and I'm actually animating the poly extrude. That's how it's actually pushing things. So you can see here it's not extruding in the right direction, but still I just keyframed from frame 1 to frame 120 the pusher UV quick shade to be able to check out that texturing is good. Same groups as for the top portion, and poly bevel just a bit, then transform, and then once again transform, and that's done. So we don't lose much of our poly extrude. Here you can see that it's set to 210 keyframe. I think in poly extrude we also should keep that, yeah, at 210. So yeah, basically it's just going up pretty slowly. We don't want to stress our particles too much. And yeah, that's our pusher, and also here's the group pusher. So yeah, that's the setup, and we will need to attach a few points. First of all, yeah, as you may see, I have rotated it 90 degrees. Let me switch this one out. So yeah, rotated 90 degrees, and it's standing on the floor. Dropped a null called out collider, and important part, drop a VDB from polygons. Voxel size in my case is set to 0.03, and then attach out VDB collider, and I will get back to this in a second. Also, bunch of ROP Alembic exports. This is how you export your Alembics. Here I just attached the delete and set the groups that I don't want. In this case it's just top and tube, and we have just our pusher, and I export the pusher. Still, it's a bit more convenient for me to work with separated Alembic files. These don't take much time to export, but you can just export one and use these groups. Now let's get to the actual grains. And if you're not familiar with shelf tools and Vellum grains, I want to do a quick example for you. So just want to show you how easy it is. Let's drop a geo, let's call it box. Maybe let's drop a box here. So here we have our box. Then pop out of this node, select your box or any geometry, and then just hit Vellum grains. That's it. As easy as it is. So here in the box, you can control your grain size. Here in the Autodop network, all the stuff with the solver is done. And in the grains, you are exporting your grains. All right, let's get back. So for our grains, here I am using an extremely dense mesh. Here you can see it. And yeah, it's basically that same circle, extruded, transformed, transformed, transformed. Probably could do that in just one transform, right? But yeah, it is how it is. And in the grain constraints, grain size is set to 0.03, and it results in a really dense and slow simulation. When you will be recreating this, I suggest you starting with something like 0.1, not 0.03, or even 0.2. And jitter scale, I wouldn't recommend you getting anything more than 0.5, because when these particles are in some sort of grid, like if the jitter scale is turned off completely, you can clearly see the grid, the constraints between them are much stronger. And if you set the jitter scale to be 1, it will be chaotic, it will be, yeah, organic and natural, but we will lose a bit of constraint stiffness. Now let me show you let's highlight the collider, but this one in our case. Nope, this one. And let's go to the Autodop network. So let me just delete a few groups that we don't need. Here, we can always just Control A and L. Keeps everything aligned. Majority of these nodes will be done and already here when you are using this Vellum grains shelf node. One thing I love to add is pop drag, air resistance set to 1.2. We will need to add a ground plane, and just type in ground plane, and position set to 0.3. Here just sits around flush with it, and the static object, and that's the interesting part. So you drop a static object here in the subpath. You just go and grab our out collider, use deforming geometry, check, use object transform, check, create active object, and display geometry. Here in the collisions, bill data, things, the shrink collision geometry is unchecked, but RBD solver. First of all, collision detection should be set to use volume collisions. After that, mode is set to volume sample, then division method set by size. Also, collision guide should be checked, and then you will see this. Then I modify the tolerance to be 0.005, and the most important thing, the proxy volume should be out VDB collider. It's basically that same thing here in the collider, this one, that is VDB. All right, and then your collision should work properly. You can play with the gravity, and yeah, you will get a few interesting results. Now let me hide the collider, and let's get to the Vellum solver. So this is a major experiment, right? There is no right properties. So first of all, substeps set to 8, constraint iterations set to 700. This is only when you are using really tiny particle. Default will be 5 and 100. You can start with it, but then if you see that still you have some weird actions going in, or particles are still breaking, not like kind of keeping their shape, you can increase the constraints and substeps. Now let's get to the advanced tab, and the only thing here you should work with is grain collisions. So here what I have set: shock scaling power set to 1. So attraction is how strongly nearby particles stick to each other. Here I suggest you starting by, let's say, 5 or 10, but when you have like these millions of particles, you can go crazy high, like 80. Attraction weight is extremely important because it's set to 0, and attraction weight set to 1 keeps your particles attracted to each other, because if it will be 0, your particles will just fall on the ground and they will never keep their shape. Repulsion and repulsion weights are just how much particles collision forces are weighted, and repulsion is how strongly particles are kept apart. I usually leave this as they are. So global weight set to 0.5 and max neighbors set to 80, because this one, basically max neighbors is the quantity of the particles, the amount of particles that will stick to each other, is the amount of particles that constraints are interacting with each other. Source scale, default, yeah, then that should be it. And in the merge, I always say that's one of the most important things: ground plane, static object, and Vellum solver, in this order, not in this order, right? So this order is super crucial. That should be done like it is shown here. And then in grains volume, I just attached the file cache, cached it out, all the frames. We can check how it looks here. All right, looks pretty good. A little explosion there, and then goes up. So I cached these 360 frames and exported as Alembic. And let me open up Cinema4D and texture and set up the lights for this animation, and I will see you in a minute. Alright, so we are in Cinema4D, and I have just drag and dropped all the alembics here. We can check them out. So our grains, our tube, our pusher here, and the top part is here. All right, so let me talk about the setup for the grains, because those are exported just as the particles, and then you should drop an Octane scatter and a sphere, and then it will scatter all these millions of small spheres. That's a pretty default workflow for any particle related Alembic files. I'm using 2 Octane skies, and one of them is just black background. And crucial part here is here in the visible environment, type set to visible environment, of course, and then backplate is checked on, but also reflections and refractions are turned on, because if I turn them off, the glass will calculate the refractions and reflections and the refractions from the actual HDRI. And the HDRI I'm using here is the blurred version of free HDRI, Studio HDRI from HDRI Heaven. Just tweaked it a bit, and also I love to decrease the gamma of my HDRIs to be 0.7, 0.6. It produces much more smoother light without harsh highlights or shadows. So let me turn back reflections and refractions. Damn, it's hard to spell these fast. So yeah, that's basically it about the materials. I'm using for this disc here. Let me show you. Here you can see that basically it's a bit dark to see. Maybe let's turn our HDRI a bit. So you can see that area here is a bit more rough on the edges. So it's done by using dark metal and this rough metal, and using a dot node and inverting the normals. That's how we get the targeting. That's how we target all these areas here. For the glass material, just a smudged glass from some libraries I have. You can see smudges here. And this is just a black plastic, nothing fancy. Now in the Octane camera itself, you see it becomes a little more bright, and what I've done is set focal length to be 80. Here in the camera imager, I enabled the denoiser. Of course, I upped a bit the exposure and added the highlight compression, upped a bit the gamma, a bit saturation, and of course this hot pixel removal. This is an awesome tool, because look how noisy it is when hot pixel removal is set to 1, and we can instantly remove some of these pixels just by decreasing the hot pixel removal. I'm using the direct lighting kernel faster than fast tracing. If you haven't checked it, you can check my video where I do a comparison of these two. The annotation will be in the right corner right now. So max sample is set to 120, but as you can see it's a bit noisy, so you can crank it up to about 180, because you know the glass, you cannot cheat here, because the glass specular materials, especially with custom roughness maps, they do require a lot of samples. Specular depths, glossy depths, diffuse depths all set to 6, AO distance set to 3. You can render out it with an alpha channel, no problem. And then, yep, everything other is set to be the default. So I'm rendering a PNG sequence of these 300 frames. Oh yeah, and camera, of course, it's keyframed. Goes up like this. Resulting in these cool grains. And oh yeah, and the grains. Grains is just a glossy material, and I like the feeling of, you know, like some sort of caviar. I don't know. So in the opacity, I added the Octane file of map and just messed around with it, so we have the edges of the sphere not translucent or opaque, and inside is more light transmitting. So this is basically it for this effect. In After Effects I just did a small lumetri color correction and also added motion blur and got this result. So thank you so much guys for watching this tutorial. I really hope it was helpful, and I hope that you will create some amazing and really satisfying animations with this technique. As always, if you like this video, thumbs up, and if you want to support my channel, please consider subscribing and check out the project file on Gumroad. Also on my website there are tons of cool stuff. You can check out asset packs, other tutorial files, and much more useful resources. I'll be back very soon. Bye!